Ah, yes, the Virgin Cave. And no, I'm not talking about this type of virgin. And I'm really not talking about this one either. The one I'm talking about is the cave in New Mexico, and it looks a little something like this. As water drips into the cave, it passes through many different minerals, but we primarily focused on lithium carbonate and vaterite. Now, with regards to the lithium carbonate, as water passes through it, it dissociates into lithium plus ions and CO3 2 minus ions. The concentrations of these can then be calculated. We can then use the concentration of these CO3 2 minus ions to calculate the concentration of all sorts of other ions, including the real concentration of CO3 2 minus, HCO3, OH minus, and then from there we can find the H3O plus concentration as well. We can then use this concentration of CO3 2 minus ions to find the amount of calcium 2 plus ions using the solubility product constant. And this is because everybody knows vaterite is far less soluble than lithium carbonate. Now you're probably wondering, what happens when hydrogen sulfide gas seeps into the cave and interacts with oxygen and different minerals? Well, let me tell you. As hydrogen sulfide gas interacts with the oxygen, it's going to produce a couple different products. It's going to produce sulfuric acid as well as solid sulfur and some water. This sulfuric acid is then going to interact with the vaterite as well as water to produce gypsum as well as carbon dioxide gas. Now, as the hydrogen sulfide gas interacts with lithium carbonate, it's going to create lithium sulfide as well as carbon dioxide and water. Lastly, hydrogen sulfide gas is going to be oxidized and become rhombic sulfur or solid sulfur, and we can use this to determine the entropy change, enthalpy change, as well as what temperatures it's going to be spontaneous at. Look at these little critters go. You may be wondering, when is the cave most biologically active? And that's going to be when the hydrogen sulfide gas rapidly degasses into the cave because certain archaea and bacteria are going to thrive on consuming that gas. Now, when we consider the reaction that occurs with the oxidation of hydrogen sulfide into rhombic sulfur, we found that the enthalpy change was negative. This means that the reaction was exothermic, or it releases heat. So not only are the organisms benefiting from consuming the hydrogen sulfide gas, but they're also benefiting from the heat that is released by its oxidation to become rhombic sulfur. As previously mentioned, the sulfuric acid is going to react with the calcium carbonate minerals to create gypsum, and the concentrations of calcium and sulfate ions are going to reach a saturation around 0.6 grams of gypsum dissolved in 1 kilogram of water. Now this is going to lower the freezing point of this water to negative 0.02 degrees Celsius, which really isn't that drastic of a change from 0 degrees Celsius. However, when it comes to osmotic pressure, the new concentration of ions is certainly going to impact it. We calculated the new one to be about 20.02 kilopascals. What this means is that basically the water is saltier than normal cave water. This will certainly impact the functioning of the organisms in this environment because it creates a hypertonic solution. And when we're dealing with microscopic organisms with semi-permeable membranes, it'll cause them to release water into the environment and they will shrivel. It's really not good for them and definitely not an ideal situation for them to live in. Lastly, you're probably thinking to yourself, but what happens when hydrogen sulfide enters the cave in the first place? So the potassium-containing mineral alunite is going to form, which looks a little something like this. After its formation, potassium-40 decays to 40 argon with a 1.25 billion year half-life. And this argon is trapped in the mineral, so we can use it to date the periods when hydrogen sulfide first entered the cave. Using this information, as well as the cave's age, which is 11.45 million years old, we were able to determine the fraction of potassium-40 that is converted to 40 argon since the alunite was formed, and we found this to be about 0.63% conversion. So thank you for taking this journey with me to the chemical depths of the Virgin Cave. See you never.